All right, you guys, today we are going to be taking measurements of a car traveling at maybe a constant velocity. We're going to be making a position time graph from doing that. Here we see the setup. I have in my room divided out equal intervals of 0.5 meters. All of them are marked with a post-it note. As you can tell, I put a line here. So this is the start of the zero meter mark. And then the start of the 0.5 meter. So when we're going to be taking measurements, we're going to make sure that we record the time when it hits the beginning, not over here at the end. When it hits the beginning. It's a nice 1 meter distance right there, and we have several of them measured out. We go all the way to 5 meters down here. As you can see in the upper right-hand corner, we have a time being recorded, and we're going to use that time to make some measurements. So let's go ahead and get started. Okay guys, I'm going to show you how we are going to analyze the data that we got from this video. So let's go ahead and dive right into it. First thing we're going to want to do is the video. It's going to be here on YouTube. It's all in this video right here. We want to go back to that lab data and see what we got. A really useful tool, and you're going to need to use this, is that in full screen mode in YouTube, we can play around with the frame rates. And so let's do this. So let's take a look at, right now this is the very start of the cart moving, and we can see in the timestamp it starts at 10:21:05. And so what I'm going to do is it's 05.4. I really just care about the last few digits there. 10:21, it's all going to happen within this minute, so I'm going to start my recording at 05.4. And so in that screen time, I'm going to record that as 05.4. And what do I really want this to be? Well, I really want this to be 0 because I want to start at 0, 0. Now let's figure out, can I record, I'm going to go back to full screen here, how long, or exactly what time we're at 0.5, and I can. And a really useful feature is you can go frame by frame. How I am doing this is just clicking the period button or the greater than sign button on your keyboard. You need to be in full screen to do this, but go ahead and give it a try. Full screen this video, and you can pause it and then frame by frame forwards or backwards. Now look at the complete control I have to figure out what time did we reach that 0.5 mark. I would say about right there, and that is 6.9 seconds. All right, and remember we are recording where that arrow is, so we want to record the time it took to get right here. This is our 0.5 meter mark, and I'm going to say that's 1 frame later, about right there at 0.69 seconds. So now recording that at we're at 0.69. Oops, 0. There we go. 06.9, and then my adjusted time. Well, how am I going to adjust? How much time later was that from when I started? Easy. I just have to do the same adjustment each time, which is going to be 0.69. Here we'll make a new column. How about we call math? Math. And how did I do this first one? Well, I needed it to be 0, so I did 0.5.4 minus 0.4, and that got me equal to 0. 0. Now in this one, I'm going to do the same exact thing. I'm going to subtract by 0.5.4 because that's the time frame that I want, and then this gives me a really good time frame. 0.5.4. So how many seconds did it take to get from 0 to 0.5? Well, that's 1.5 seconds after we started. Let's do this again for the next one. Now I want to record how long does it take to get to... Oh, you don't need to be in full screen. That's good to know. The 1 meter mark, so I'm moving. I'd say probably about right there, and that is at 08:03. That's the time frame that we need. So 08:03, 08.3. And then I'm going to do 8.3 minus, I'm going to lose these zeros for now, they're not really important, 5.4, and that's going to be equal to minus 5.4. Well, you might be thinking, well, don't we want to subtract by the 0.69? Well, I would if I wanted to know the time it took to move from here to here. But I don't. This time that I want this to be how long it took to move from 0 to 1. Because after 2.9 seconds, where am I? That's really what I want to know. Let's do this one more time, make sure that we got it. Move us forward to 1.5. That's about right there. And I'm going to call that 9.7. 0.97 or 9.7. 9.7. Again, I'm just going to subtract that 5.4. And then that's going to tell me 9.7 minus 5.4. And that is going to tell me that it took 4.3 seconds after I had started. I now know the exact position of the cart after like 4.3 seconds after we have started. And that exact position is 1.5. I don't need the time it takes in between here. I need the time it takes for the cart to have reached each position after we had started. And we're just going to assume that we start at 0, and we can see we're just going to continue to go up and up and up and up. All right. That is everything. Next up, I'm going to show you how to, well, let's go ahead and fill this table. Through the magic of skipping ahead, I have filled this table. All right, now we have a completed table, and now I'm going to show you how we are going to make a graph of the position versus the time values, and we want to use these adjusted times. I just took in the previous video. I am now going to make a position time graph out of it, and we don't need anything fancy. You could do this on graph paper if you wanted to, but all I'm looking for is a general know-how of how we are going to make this graph. And so we're just going to start by making our axes. This is going to be my y, it's going to be my x, and I know, then we're going to label these. We know we are going to graph position on our y-axis, and we have this measured in meters. We always label, and we put the units that we have measured in parentheses. And we're going to have time on our x-axis. This was measured in seconds. Now, our positions are going to be really easy. We're just going to go up by the marks that we have. So I'm only going to graph 0 to 2.5. You guys are going to graph this from 0 to 10. So keep that in mind, that you need to leave enough space for your positions and your times. For me, I'm just going to go up by 0.5. That'll do. We'll do these in a different color, but I just call this 5, 1, 1.5, 2, 2.5. Beautiful. And now I need some times. Now what I do not want is each one of these individual times just put somewhere onto this axis. That's not how we're going to get a good looking graph. We need to have consistent jumps in our axes. So just like how it worked out really well that I planned to take position measurements at equal intervals from 0.5, then 1, then 1.5, we need the same kind of thing on our x-axis. So let's go, I need from, let's say 0 to 8. So that was 1, 2, 3, 4, 5, 6, 7, and 8. Now this was very important that I didn't just mark. I need to make equal intervals. I need my axis distances to make sense. They don't need to be perfect. They definitely aren't perfect. I just eyeballed it here. But now I'm going to fit my data into what I have here. And like I said, I'm just going from 0 to 2.5. When you do 0 to 5, you're going to need enough time on your x-axis, probably be from about 0 to 16, maybe enough spaces to fit in there. You do not have to put every single one. You can go up by 2s, go up by 3s, whatever makes the most sense to you. You just need to go up by equal intervals, and you need those intervals properly spaced out. So now let's go ahead and put our first data point in here. I'm going to put all my data points in green. 0, 0, that's an easy one. Now at 0.5, we are about 1.5. So now I go up to 0.5, and 1.5 looks about right there. And I'm just eyeballing halfway between 1 and 2. Next, we got 1 at 2.9. Well, that's really close to 3. I might just do a little bit over there. Perfect. Now we got 1.5. We are at 4.3. 4.3 is a little bit more than 4, but not quite halfway. So that's going to be about right there. 2 second, or at 2, we're at 5.7, so a little bit more than halfway. That's going to be about right here. And at 2.5, we're at 7.2, so a little bit more than 7 puts me about right there. Now again, I am just eyeballing this here, but now I have a pretty good position time graph where I now know and I can fill in the dots with a nice dashed line there. We know. We can see that this slope is pretty constant, even just from eyeballing. So we know if we have a constant slope, then the velocity must have been constant for that cart. And then we can extrapolate any information. So maybe I wanted to say, well, what about right at 2? Where do we think we were? Well, if I had a nicer graph, we can still make a little bit of an approximation of where do we think we're going to be. Probably about 0.6, 0.7 in that area right there. All right, that's how we make a graph. So go ahead and finish. So you need to take the rest of your data. So we can use my 0 to 2.5, but we need to get our 3, our 3.5, and all the rest of it, and we need to add that to the graph as well. So your graph should include more than my graph does. It should keep going this way and keep going this way to have all of the data from this cart. All right, this time around, we are going to be moving backwards. We are going to start at the 5 meter mark, and we are going to travel in the negative direction. Let's see what we get. Noticed that in this video, we do not start at a low enough time to just do the subtraction method for finding the time. So in the last video, as we can see right here, we started at 5 seconds, and then everything was just greater than that because we didn't go from any more than about 20 seconds. But in this video, we start at 56.3 seconds, and really early on, we go over. So if we do the same method, what's going to happen is we start at 57, and then I subtract. We can do that for the first one. Then I'm at 58.8, and I do that subtraction of what I started at, which was 57.4, and I subtract those two. Well, that's great to find this time. And that can even work to find 4, but then right here our time doesn't keep going up from 60. We reverse and go back down to 0. So think about a good method of combating this. And what really works out well is we are going to say at 4, we are exactly at 0. That's going to be our time frame. Well, with the subtraction method, we can get these first 2 intervals, no problem. And then if this is 0, well, then we can just get the next interval, right? It would be about 0 to, we'll say that's 1.3 seconds. And we are going to then just add that 1.3 seconds to what we had gotten in our first 2 intervals. So let's say if this one was about 1.3 seconds, and then this one was about the same, about 1.3, maybe 1.4 seconds. Well, then in total, we've been traveling. This point should be, we are at 4 at 2.6 seconds overall. And then we're going to add this third 1.3 seconds. And then at 3, we were at 3.5 at 1.6 times 3 at a total of 4.8 seconds after we had started. And then we can just keep adding the times on top. So we have a continuously rolling time as we're moving backwards. All right. All right, this time I just wanted to give you a little overview about what you're about to see. So these carts have a nifty little property that they can flip over when they encounter a solid wall. Look at that. So what we are going to be doing is I'm going to start at 0 and we're going to move down. This is 2. This is 2.5 meters exactly. When it hits here, it is going to be at rest for a certain amount of time. And we're going to record that time it takes to flip over. So we would start now and stop. And then we will record the time moving backwards when it gets to 2, and then 1.5, and